All right, so let's get started. So this is a USACO class, and then last week we reviewed the real problem from the bronze division, and that one I say is not an easy one in the bronze division. So I give out a homework, actually a challenge, and to my surprise, nobody did the challenge um, problem. So I'm not sure if
We number 16.
I'm not sure if it's you guys do not have time to do it, or did you guys have spend any time to review the problem?
Oh, wait, is it the one? Is it the one with like equivalent strings?
Yes.
Yeah, I turned that in.
You submitted it?
Yeah, yesterday.
Oh, okay, probably, yeah, probably. I checked it before you submitted. Sorry about that. So let me double check it. And
I don't think it's the most efficient it can be, but it works. I think.
that's good. We are a class, so we wanted to practice, and eventually we will get to it. So you don't need to worry about if it's efficient or not. So that's good, Derek. So you submitted it. So can you talk about your solution then? Do you want to
I can
share your
try.
screen?
Yeah, sure. Give me a sec. Do. Share. Okay, hello. So you have your inputs, which are these, and what this block of code does is basically it goes through this string and then adds each unique character in that string to one of these lists. And then after that's done, it'll turn the strings into lists so I can like iterate over them later. And then the first if statement allows me to just cut it out, to just stop the code there if they don't have the same number of unique letters, which is like one of the things that's really important with it, is that they have the same number of unique letters so that you can have a one-to-one thing. And then if not, it'll basically iterate over the list, both lists, and basically see if a character, and basically take like one of the you know what, I'm just gonna write it out. Okay, so we have string, I can't explain it good, but like we have the list A, B, B, and then we have the unique characters within said string A and then B. So what'll happen is it'll keep iterating until it can find all of these, matching letters, and then it'll give it a number depending on the index of this unique character. So this will become 0, and then this will become 1, and this will become 1. And then what it'll do after it does this for both sets of unique letters and strings is it'll basically check if these two lists are equivalent, like these two lists are equivalent, and then it'll just say it. I don't know if this is super efficient or good, but it worked for me.
Okay, so let me see. I do not fully get this part when you draw the list. You have like A, B, B. So that's your unique one list, or that's your string.
So this
Yeah.
is what I'm calling the string because later I turn it into a list. This is the
Okay.
unique characters.
Okay. That's a unique ones. But you do not consider the position of the strings, the character. Do you? So
It
where do
does.
you,
It does. It.
which part?
So what happens is because it's like a range length, this will be, it'll, because of this line where the string becomes J and then it'll become whatever index this is, you'll have like a unique sequence where it'll be like 0, 1, 1, and then 0 if it's A, B, B, A. And then when you iterate through the second string and you have the unique 2, it'll do the same thing.
Okay.
I don't have, there might be a way to circumvent it, but I just haven't found it yet.
Yeah, probably, I probably need to, I'm sorry I did not see your submission. I was busy today,
Hello.
so I did not check it. I checked it yesterday, I think the day before yesterday. I did not see it, so that's why I did not check it. So today, so that's why I did not get the time to review your code. I will take a look at it again. So let me read through your code.
Yeah,
And
I submitted it pretty late last night. Sorry.
oh no, not your problem, and no worry on that. Yeah, I will understand your solution, and then I will comment on yours, because right now, so we can discuss this. Okay, right now the first two for loops, and you try to get the unique ones. The string 1, string 2 now become list. So if links unique ones, links unique 2, okay, so that will not equal. I think that makes sense. But it does not take care of the length of string 1 and string 2, right? You only compare the unique 1 and the unique 2 to see if the length is equal.
Yeah, but at the end of the thing, it's like if I could probably put and or like an or thing and or an or function here to make it, the same thing, but I wasn't like in a little bit of a time crunch, so I kind of just went with it. Because I kind of went, I had the basis idea of just looking at the unique characters and then doing other things, but I kind of didn't have it fully fleshed through when I started coding. So I kind of just moved on as I went.
So then let me ask you, what's the purpose for string 1, j equal to I? What is the purpose for that? The line you say in the for loop, if string 1 j equal to I.
Oh, I think this might be my Java brain just kind of doing what it does, because isn't it in Java where you can't iterate over the list itself, you have to iterate over an index of the list?
Yeah, that's fine. So what's the purpose? The line, let me see if I can do the annotation to yours. So I can, so I can ask the question here. So what's the purpose of this then?
Oh, okay. So I can do it. Okay. So what happens in the code is you have your string set, right? A, B, and then C, right? And then you have, actually, I should probably have them. So you have string A, B, C, A. And then it'll have, and then you have the unique characters A, B, and C. And so what'll happen is it'll keep iterating until it finds, one of these matching characters. And then what it'll do is it'll change this letter inside like one of the inputs into this index. So this becomes 0. And then this becomes 1, this becomes 2, and this becomes 0.
Oh, I see what he meant. Okay.
And that's kind of how I check if they're both in the same order. But again, I don't know how easily this can be circumvented.
So then you are trying to make sure, okay, yeah. I got your idea now. I got your idea. So then you compare string 1 equal to string 2, you compare these two lists. Because the list, if they have the same value, same amount of numbers, and then okay, that's actually a very, very talented sort on it. It's good. It is good. I got your idea. Derek.
Yeah, but I think I could have probably created a function for this part and probably this part.
Actually, the whole thing from the first floor to the end, you should put it into a function. Then you can call it when you solve the problem. Because when they give you, when they test your submission, right, they will just run your code, and you should have, you should be able to read in the input, and then output yes or no, or true or false. But I got your idea. That's just a trivial thing. Okay, that's just trivial thing. So I think I got your idea, and that's a very smart way actually. Can you send me this this solution, because this is the first one I saw, and it's really very smart.
Like to send you the text file on Zoom.
Oh, I do have yours. I do have yours because you already submitted it. That's very good. Thank you, Derek. So can you still share? So for the rest of the class, do you guys have any suggestion? Or can you guys ask Derek a question, which part you do not understand on this solution? Okay. Thank you, Derek. Very good.
Okay.
Very good. I will make you the winner then. So I will update my list and make you the winner for the last challenge. That's very good. And that works. And the logic is right. For the class, I really want you guys to spend the time. Do it slowly, when you do the contest, you really need to write your code, right? If you are not good at coding it, then it's hard for you to do the contest. So I really want you to, do as what Derek is doing, and we will spend more and more time on the solution. So how to solve the problem and get you guys to practice on it. Okay, so let me share my screen. Thank you, Derek, for that. Let me share my screen. There are a lot of solutions, and Derek really has a very good one. I think I see your merit in it. Very good. So I just propose one if you guys did not do it. So this is one of the solutions. I think is straightforward as well. So the first thing, if they give us two strings, right? The first thing we check the length of the two strings. If they're not equal, we can quickly return false. They're not equivalent. They're not equivalent. So if they are of the same length, So what we are going to do is that we get the first character and check out how many occurrence in the string, and then its position. Okay, its positions. So that's exactly what Derek did. Derek did the position in a very smart way using the loop, get the index. That's very good. So you can have other ways to do that. You can use the index. So what you are going to do is that you get the first character, right? And the first character, of course, index is 0. Then find how many occurrence it has. So once you know it's more than one occurrence, then you just do index of, index of, index of. So you keep doing that. You're starting from the position of the last occurrence, then you will get the next occurrence, the index value, right? So you will get that. So once you got that, and then you can compare if the position or the index value are the same or not. If this one is not the same, you can quickly quit the comparison or the loop, and you just say no, because that character, they're not equal. If they're not equal, because the occurrence is not the same, the position is not the same, then you don't need to worry about the other characters anymore. So you just return. So you keep doing that. So if it's the first one, if it is true, you remove it. You just remove it from the string. Now you get the first one after you remove it, and then do the same thing. How many occurrences it has, and if they are the same or not. If not, it's easy to say no, it's false. And then you keep doing that until the string is empty. If it's empty, that means they are all good. Okay, everything matches, then you return true. You end it. Does this solution make sense to you guys?
How would you check the positions? Would you just iterate?
Okay, so the position we can check. We can check it this way, okay? You in your code, you will use index of, right? So there should be an so this problem. So let's do the index of both in the both Java and Python. You can do that. You can get the index value. So that's the position. You have the character. You get the position. Let me go to the Java. So let me just show that to you how to check the index value. And of course, we can do the same thing in the Python as well. Java string. Okay, you see Java string, it has an index of. So you get the first character. Of course, the first character, the index value is 0, right? But now you need to check how many occurrences it has. So in the Python, it's easier to do it count. If you do count, then you know how many occurrences. And then you say the index of, and then you can use the from index. So if you use Java, index of the first one, of course, is 0. So then you starting from the last index of value 0. And starting from 0, then you get the next index of, and you get that. Compare if they're the same. If they're same, then you go to the next one. You put that index value here. Let's say now it's 3. Put a 3 here. So it will find the other value, the other one, the next one. You compare it. So that's the way to compare if the index of value for that character is the same or not. So you can do that. So you say, let me say, if X is a string, I will just use index of. So I will say that let's pretend the first character is A, and then it is the last index value, right? So let's say it's 3. So now it's start from 3 to search it. You will get the first occurrence of A in that string. So you will get that index value as well. And you just compare that. So if let's say if they are equal or not. So Y, okay, index of this is Java, okay. E also is 3. If they are, okay, let me do this. If they're not equal, but they're not equal, then you can easily return false. Your process is over. They're not equivalent. If they are, so usually if they are, you want to set the value equal to this one. You can do this. To be easy, you can do this. X index equal to this one. Okay. Y index equal to this one. Okay. So this will, I can put this index here. So that's easier for you to understand. That's the last index when you do it. So now starting from this position to search the rest of the string to find out. So now what I just need to compare that if X index equal to Y index or not. All right. So if this is a loop, let's just say while true. Okay. While true. We will just do this. Keep doing that. Okay. Of course, you need to have another. You need to have another one. So if now if X index less than 0, you break. So it will not be an infinite loop. You put it here as well. Y index. So either one, if they cannot find it, you break out. Okay, if that's the case, you can also just for for your consideration, you may be able to put some code here. If that's the case, and if we reach the end, then we can return true. All right. So of course, this is not the A. This should be the first character. Or with the first character. You just need to put more code there to implement this one. In the Python, it also has a Derek. So let me show you. Let me go to Python. String. I think when I do level 1, we do have that. We talked about that. So let me show you there. Let me show you the index value. There is also an index. Let me just search it. Let me go there. For Python, it's level 3. Yeah. We have a method to get the index value. Hmm? Yeah. So let me just give me a second. So I will find the index of. So you say Python string has this method as well. So you say index. So you give it a string, it will tell you. The problem in the Python is that if it doesn't exist, it will give you an error. It will give you an error. So you need to do try catch. Okay, try accept it. In the Java, if you do index of, if it does not exist, it returns -1 value. But in Python, if you use index, it does not exist, it gets 0. Okay, so it's also have the start end. You just search for that. So you can have the start position as well. I'm not saying that this solution is better than yours, Derek. So I think yours does have merit in it. Very good, actually. So let me ask the rest of the class. Did you guys really think about this problem, and how do we solve this problem for the rest of the class? Okay, it's quiet. Okay, so let me do not spend too much time on this problem. If you guys are quiet, because I really want you guys to read the problem, think about that. If you come up with a solution, you have to do that. That will help you. If you do not do that, even I talk about this, you may not understand it at all. So that will be a problem to you. You will not make progress. Okay, so the next one. Continue working on a real USACO problem. It's also a bronze problem. Let me get that to you, okay? Let me get this one to you. This one, I think you can also go to the shared drive to download it. And spend like 10 minutes with it and come up with an idea so we can talk about the solution. So it's problem 5, okay? Problem 5. So can you go there and download it? And I can share mine here. So this is a problem. Read it, spend 10 minutes on it. Then let's discuss the solution to it. You guys need to download that file. If you do not download it, you need to watch my screen, read the problem, think about that, see if you have a solution for it. We will discuss this. I will call you guys. I will ask you guys one by one. If you already have a solution, then you can volunteer. Let me know. Send me a private chat or just speak up. Either way is good. You even send a chat to everyone. It's also okay if you have a solution. If you can finish a flow chat, that would be great. If not, if you can sketch something, it's also good. And really want you to be able to talk about that. So what your solution is. Anyone has a solution? If anyone come up with a solution, then I think we may have enough time for thinking. So we will come back to talk about the solution. So if you already have one, you come up with one, you can let me know. Or I will still let you to use the time to think about that. So I will stop you guys at 7:30. All right, so let me stop sharing. Let me ask you guys, see if you guys come up with a solution or not. You can be straightforward. You can just tell me, oh no, I do not have one. Okay. All right. So I do not see Alex here today. All right. So let me ask Alex.
Hello. I don't think my solution works, but I do have one that I thought of.
Yeah, can you just talk about that?
Okay, so you just make a 2D array of the board, so like with the grasses and stuff. And then after you made the 2D array, you search through every cell. You search through the 2D array using for loops and check if the cell is grass. And if the cell is grass, you subtract one from the index or add one and try and find if there are two cows next to it. And then once you detect two cows, then you can delete the cows in the grass cell. And then you repeat that through the entire 2D array. And I don't think that works because, it could mess up by like accidentally deleting a cow that was necessary for like a different grass cell. So I don't know.
Yeah, you are exactly right. So if you delete it, it will remove the possibility that this car may develop a friendship with another car through another grass. So you cannot delete it. But you are searching for that. And another thing I think you may get into an issue is that you just increase the index by one, so it's like an row index or column index, because you do not have two costs do not have to be in the same row. They can be in a different row. They can still be a good friend. So that way, if you just do that, it may not give you the right answer. So let me ask Thomas. Do you have any solution?
No.
Okay, then let me ask Chloe. Chloe, are you there? Gloria. Melvin.
Not yet.
Not yet. Okay. So Emerson. Emerson.
Oh, I don't have the solution.
Okay. Then Alan. Alan. Serena. Okay. All right. So Alex, very good for your speaking up and talk about what you have. We really needed that. If you do not have a solution, think about the last problem we solved. It's also talking about the grasses, right? Actually, cells. You actually see that we eventually need to come to another very important topic in the programming. That's the data structure. When we in our session 1 class, we're using the 8 queens puzzle. And I showed you a solution, and we create a new class, and that's a data structure. And you have that class has properties like rows, columns, and eventually we will talk about this as well, because if you can think at that level, you see, okay, this probably talk about cells. So it has row, it has column. So I should be able to create a data structure or a class that can handle this kind of situation. But that's too advanced to us at this moment. But in the future, when you come to this kind of a problem, if you learn that skill, it will easily help you to think out a solution like that. But based on the solution or the skills we have learned so far, I can propose 2 solutions. So let me share my screen. I want you guys to think about this, okay? This problem can be solved using combination, okay? It's actually test your skills on combination. So what do you mean combination? I pull 1 call. Let's say I have 10 calls. So the call 1, call 2, call 3, call 4. Okay, let's just use 1, 2, 3, 4, 5 to 10. So you have 10 calls. Now you are trying to generate the combination. A pair is a combination, right? So you just need to generate the combination of the calls. 1 can be combined with 2. 1 can be combined with 3. 1 can be combined with 4. You just keep going, right? And you get all the combination. And when we learn this basic skills, we see the complexity. When you do combination, what kind of complexity it is. So let me just go back to that. Hopefully I still have that here. So combinations. I do. Okay. So when we do that, so here, here is the complexity we have. So you have 10, you look this 10, and you then do another loop, get a 10, because you are trying to get a 2 out of 10. So that's a combination. The combination is n squared. So you just do 2 loops. So you have loops like a 1, 2, 3, 4, and you get 1, then you can combine with 2, with 3, with 4, and then you get a 2, and now you combine with 3, 4, 5, right? So that's just the 2 loops, and you get all the combination. So after you get the combination, you just trying to check if that 2 pair, if that pair has a shared grass or not. If not, eliminate it. Okay. And then what it left to you is all the friends, the potential friends. But you need to be careful to remove the duplicates. But if when you do that combination, you say you pull 1 out, you combine with 2, 3, 4, 5, 6, 7 to 10. When you pull 2 out, you are not going to combine it with 1 again, because 1 has been used to combine with other numbers. So that way you will not have duplicate. You will not have duplicate, right? But you need to be careful on another thing is that if this pair using a grass cell to build the friendship, but if this grass is also the only grass cell shared by another 2, then you need to eliminate it. You need to eliminate it. So this where you say you can solve it using a combination. You solve it by combination. So does this solution make sense to you? You just do the combination, and then you check if they have a shared grass cell. If it does have a shared grass cell, then you just keep that and put the grass cell in the list. And then you check the other one, the next pair. Okay, so does this make sense to you guys? You guys are so quiet. If you want me to ask you, let me stop sharing. Then I ask you.
Is there a way for them not to share a cell? Like a possible cell?
I'm sorry.
Like on the thing it says eliminate all like pairs that don't have a cell, but is there even a way to prevent the cows from having a cell?
Yeah, there is a way to prevent it. Let me show you that statement. This one. If a pair during the process, they eat the grass in the grass covered square, so future pairs of cows cannot use that square as a meeting point. So that's why once you use that grass cell, you need to eliminate that grass cell. It cannot be used by other pairs anymore. But you know, the first thing you get the combination, and that means you form different pairs. So that's an easy job. That is an easy job. You just pull 2 out and form a pair. And once you get a pair, then you see if they share a grass cell. So if they are like if they have 2 rows apart, If they are two rows apart or two columns apart, then they cannot be a friend. So you just eliminate that pair. Okay. So if they are not, if they are like just one row apart or one column apart, then you check if they have a gross cell they can share. Okay, so that will be a way to solve it, and its complexity is in square. But actually, there's another simple solution. You need to get to this one. And Alex mentioned the partial of it. So we can use that solution, okay? The smart solution is actually to find out the gross cells that has two or more costs next to it. So you get all the data in. You just need to find out the gross cells. How many gross cells you have, okay? And once you get the gross cells, now you're just trying to eliminate those gross cells. It does not have two costs next to it. Once it has two costs next to it, no matter who those costs are, it is a place for them to develop a friendship, right? So actually what you do is just to count the gross cells that has two costs, next to it, okay? So once you get that, and this is an easy job, right? This actually, its complexity is just like, sorry. Its complexity is just like O(n). Because you just needed to look through all the cells to find out which one is a gross cell. Which one is a gross cell, okay? If you know that, keep it. And then you just check it to see if this one needs to be eliminated or not. All right, so after you finish that, so now you just need to eliminate the duplicate pairs. Because one gross cell may be good for two costs, and there's another gross cell. They are the same in the same situation for those two costs. So then you eliminate it. So that number will be your answer. That number will be your answer. I'm not sure if you guys get this one. Get this solution? It's too hard. I need to ask you guys one by one then. Okay, that's a good question. Okay, Alex. So let me just do it this way. Let me get in a notepad to do this. So if I have a call 1 and a call 3, that's a pair. And they are a friend. They are next to my gross cell. So now I get a gross cell. Now it has like a call 1, call 5. Okay. All right. Then I get another gross cell. Now this time it's still call 1, call 3. And then it is in a duplicate, right? So how do you do that? Derek already have the code for his last solution for the last challenge question. You can use if it's innate or not. Okay, you can use that to change to check it. And that as in the list, okay, if your list is like this 1, 3, and you can put this as an item in the list. Okay, let me do this. This is a tuple. If you put this in the list, then you can check it. If you get this pair, you can check if this pair exists in it or not. If it does exist, you do not need it anymore. You eliminate it. So that way, you will get your answer. And do I answer your question, Alex? You say you get in the grass cell and you will find out which two calls are next to this grass cell. If you have that, then you just use this to form an atom, like in a tuple, like that. Of course, not exactly the tuple, okay? So you need to have something to make sure, you need to make sure, okay, this will represent that call. And this represents another unique call there. So once you have that, it's easier for you to eliminate it. All right, it's 47:47. I think if you do not give me any feedback, I really don't know if you got my solution or not. Melvin, can you give me a feedback? Does this make sense?
Yeah, like I kind of get it. Yeah.
How about you, Thomas?
Yeah.
Okay, I hope this can help you. But in the future, you see, if I get to this kind of data, like we do at Queens, I create a class called cell. The cell can have 3 or 4 properties. And then in the cell class, I will set how you determine if it's equal or not. And you have that method defined in it. And now, when I read in data, I can create all those classes. So those instances, I put them into a list and I quickly run through this list. And then the problem is solved. So I think I will start to talk about a data structure. If not next week, then the week after next week, we'll talk about that. So that will help us solve this kind of problem. But you do not have to use it because in bronze problem, you do not need to get to that level. Okay, you do not need to use that at advanced scale. But once you get into silver and gold, then data structure is very important. You need to build your own data structure. Okay. All right. So I still have the challenge question here. I want you guys to do that, and then we can come back and to talk about this one. Then we can learn more stuff. So I will give this challenge question to you guys. I will read through it. Tom, Matt, and Andy are playing basketball. Tom only shoots for 3 points. Matt never shoots for 3 points. Matt does not score if Tom scores. Andy shoots for 3 points if Tom scores. Or he just shoots for 2 points. Everyone takes turn to shoot, and Tom always goes first. Anyone can fail in any round. When I say fail, that means you score 0. So after 5 rounds, the total scores is 20. So please print out the total score that each can have. There is not one solution, okay? There are multiple solutions to this. So how can you get 20 points? So can we think about how to do this one? All right, if you don't have a question, I will just put this in the classroom. And Derek, you are the winner for the last challenge problem. Okay, so any question? I will return the class back to Ms. Key.